We're going to go through teaching the Apollo spacecraft today. As you can see, we are mounted in our Saturn 1B attached to the service tower. So I figured I'd just go over to the little basics today. So in order to queue up digital checklist, you're going to select DX9 external MFD. Select twice, 1, 2, Apollo checklist. There are no checklists right now, but they should automatically queue up with the startup checklist. Inside the spacecraft, you can press F8 to go into the 3D cockpit. To read the checklist is very simple. The left has the line item. The dash separates the line item from the action, and the right has the action. In addition, there may be subjects in parentheses telling you that there are 3 of something or 2 of something. And on the far right, very few times you'll see a panel number. And this will tell you locations of buttons and switches during the startup, but as the mission goes on, these will get less and less. They will continue to be put there for switches that are not used very often through the mission and when you change panels. Interfacing with the computer, we can see V for verb, N for noun, E for enter. So let's get started. The first thing you see here is the caution and warning power 1 up. The caution and warning system is located here on the spacecraft. Its job is to give any error status on any system which would be related to each light. For instance, the caution and warning is not powered on right now, so the caution and warning annunciator is lit up. This either means that the caution and warning system is not powered on, or there is a fault in the caution and warning system, preventing other errors from being displayed. When we power it on using left click on the power switch, we can see caution and warning annunciator goes away, and 2 error lights come on, followed by the tone in the master alarm. Notice in the checklist, you have PB, LT, CB, sometimes FW. Alright, so SW is a switch. When the checklist says caution and warning, C/W, you look for the big text at the top, and the next word will be the small text, power, so you find the power switch under the caution and warning. You can see 1 and 2, on and on, but system 1 is up and system 2 is down, middle is off. Many switches in the spacecraft are like this. Some of them are just simply on and off, like cabin fan. 1 and 2, where up is on and down is off, and systems are separate. So you can see this is an example of a thumb wheel. This is an example of a switch. This is an example of a spring-loaded switch. This is an example of a cover. This is an example of a push button. This is an example of a guard. Here is another cover. This is a selector. These are examples of adjusters. Here's another selector. Here's another selector. Thumb wheel. And circuit breaker. Here's another example of a switch. And let's continue forward. This is the command module computer, also known as the Apollo Guidance Computer, the AGC, or this interface specifically will be referred to as the DSKY, D-S-K-Y, display keyboard. The checklist will now ask for you to power it up on panel 5. You can see it says circuit breaker, so you're going to be looking at these. Guidance and navigation, G/N, guidance and navigation. Computer, subitem computer, subitem main A, and main B close. And you can see that the checklist will automatically proceed. It is now asking for the CMC light to be off, and that it is. The computer will also have program alarm and reset. So hit the reset key on the computer. And the checklist now asks you for verb 35, enter. Master alarm, you can push any one of those three. And this is the command module computer status lights check. Verb 37, enter, 00. Verb 37 is used to change programs, and the 2-digit code will be what program number we load. So 00 is the idling program. You can see we're now running program 00. To power up the IMU, we're going to come up down here, open this guard with right click, left click, and then right click. No attitude light will then be displayed for 90 seconds. And the no attitude light will go out. Once out, FTAI power can be set to 1. And on panel DSKY, you can insert verb 37. Please change program, enter. Flashing means that there is an input required, 01, enter. The no attitude light will then come on, and the ball will align to our launch azimuth. Once done, the no attitude light will turn off and program 2 will start automatically. You can disable FTAI GPI power. This is the FTAI, the Flight Director Attitude Indicator, and this is the GPI, Gimbal Position Indicator. It also shows the launch vehicle tank pressure status, so keep that in mind. The checklist is now going to want us to do a rudimentary caution and warning checkout. Flip to 2, check the system's work. Flip back to 1, check that the system's work. You can test on 1 and hold. If you hold and you move your mouse and then you look with holding right click, you can maintain a switch held, verifying that the normal switch lights this up, but when boost is on, this turns off. Flipping back to normal and it will turn back on. You can then set the lamp test to 2. And everything looks good, and release. Flipping caution and warning to acknowledge will not in fact prevent the caution and warning alarm from sounding, but will only prevent the caution and warning annunciators from displaying. The last thing I'm going to cover during this small tutorial for the basics of the spacecraft is the EMS. Quite a complicated little system. It's very similar to the abort guidance system in the LEM, but less computery. After that, we'll cover some of the irreversible actions, and then we'll call it for the time being, so that you can familiarize yourself with the spacecraft, the different terms for switches, and where they are located. The GTA switch is in this cover. Right-clicking the cover will open it. It is a little difficult to find the click spot, but it's typically right here in between the gray and the red of a switch. Of course, right-clicking the switch itself will set it to down. So flip the ground test actuator on. And now we are going to run a null bias check. Null bias check means that we're going to monitor the delta V to make sure that it changes less than 0.1 feet per second every 10 seconds whilst in the delta V monitor mode. Set the selector to delta V and the mode switch to normal. A minus sign may appear, and this is normal. The minus sign may blink rapidly, and this is normal. Just as long as this number doesn't change, you have a good null bias. After 10 seconds, and the number hasn't changed, you can leave the mode switch in normal and select delta V set. Make sure that you are not on VHF ranging. With delta V set on and the switch in normal, or the up position, you can use this thumb selector, the delta V EMS set incrementer and decrementer. You can hit up with the left click to 1586.8. One 586.8. You may notice when you get close, left clicking is somewhat inaccurate. You can switch to right click to move to 0.1 increments. 1586.8. You can now set to delta V test with right click. The SPS thrust light will turn on and this number will decrease. The test will ask you if the final number displayed is between negative 20.8 and positive 20.7. So our cutoff test is good. We can go back to standby and we can select off. The next part we'll cover is the RSI and the trend recorder. Setting the EMS test to 1 and to normal, we can see all lights are out and we are displaying 0.0 nautical miles. We can use the selector to slew the trend recorder to the test pattern. Notice the scribe. Once set to test 2 After 10 seconds, the 0.05 G light will turn on. We have the light. Switching to test 3. We can see here test 2, 0.05 G light, test 3, 0.05 G light, and the down lift vector. We then need to set to 58 nautical miles. There's our down lift vector light on the RSI. Range set to 58. Switching to test 4, for 10 seconds, the scribe will trace the pattern. It does not need to be exact. It only needs to draw for 10 seconds roughly and stop at 0. Once at 0, we can switch to test 5, and the scribe traces vertically to 9G. After 10 seconds, the lift vector up light is on, and going to range set, everything resets, and the scribe I just had a mind blank. The scribe will max out. Peg, right, the scribe is pegged at the top. Flip the mode back to standby, and the EMS to off. Going left. Do not reverse through the tests. Ground test actuator switch off, and right-click on the gray-red part to close the cover. This is our lift vector indicator with EMS roll on. This will monitor our roll and yaw through and will adjust accordingly. Lift vector up means we will pull out of the atmosphere. We'll take a more shallow approach with less G's, but we run the risk of skipping out if we're from lunar orbit to Earth. With that much delta V, we can skip out. In Earth orbit, it is not much of an issue, but you'll be very far away from your designated landing point. The horizontal indicators will stabilize the G-forces, but they will also cause the spacecraft to move right and move left. The down lift vector light will cause us to dig into the atmosphere steeper, incurring higher G loads. The trend recorder here for re-entry will show a trend of G-force on the y-axis and velocity on the x-axis. And that is all for now. We will get started with checking our glycol loops after you've done some familiarization with the spacecraft. Ooh, right, before we go, there are irreversible actions in the spacecraft, most of which are covered. Some of these irreversible actions are semi-reversible, depending on how you view irreversibility. These irreversible actions in the spacecraft are the dye marker for the post-landing system, the thrust system, applying delta V in any translation direction, up, down, left, right, forward, backward, can be reversed, but with the engine it is much harder to do so. So we guard the engine switches,
rotation,
and consider them irreversible. IMU cage is not irreversible despite being guarded, and neither is the entry landing system logic. But we'll cover why those are guarded when we get to them, as this will be a walkthrough of the mission. Command module propellant dump and purge are both irreversible actions. Dump will open all command module RCS valves, and the purge will instantly boil off the helium. The loss of helium will cause a significant pressure change in the fuel, leading to instant evaporation of the fuel, and they will flow out of the RCS ports. The launch escape motor fire canner deploy, CSM LV SEP, command module RCS helium dump, the main deploy, the drogue deploy, and the apex cover jet are all irreversible. In addition, anything under the sequencer that is guarded is an irreversible action. CSM LM final SEP will deploy the probe via pyrotechnic system and will actually separate the probe at the front of the spacecraft from the command module, and you will not be able to dock anymore. CM SM SEP, this will separate the command module and the service module. These are barber pole because once you do this, there is no going back, and if you are not in a suborbit, you will die. S4B LM SEP, this will separate the lunar module from the ascent stage. Tower jettison will jettison our launch escape tower. Launch vehicle S2 S4B launch vehicle stage. This will manually stage the S2 from the S4B. And the main release will cut the parachute, also in barber pole, because you want to make sure you splash down before you flip that, or you're going to have a very rough day. Other irreversible actions on this panel, there are very few, but there are two. The first is the command module RCS pressurizer. So this will allow flow of the helium into the propellant to pressurize the propellant. In addition, the retract switches. Each retract switch may only be used once, so for whatever reason, if you need to redock the lunar module before you have landed on the moon, the landing must be considered scrubbed. Irreversible actions over here. Fuel cell reactance valves. These isolation valves, once set to the off position, will prevent a fuel cell from being restarted if not on the ground. On the ground, however, we can fully restart fuel cell react valves. We protect ourselves from pulling those react valves by having the circuit breakers pulled at all times until fuel cell shutdown is required. Normal fuel cell shutdown procedures, however, are just to disable the pump, but emergency power down procedures may require the fuel cell react valves to be closed. Another thing to note, some indicators serve two functions. Like this indicator here has two functions, and this indicator here has two functions. This indicators here have several functions, and all these indicators here have two functions as well. This indicator has two functions. These indicators have several functions. These indicators also have several functions. And so does this indicator here. And I believe that's all the basics that I'm going to be covering for now. The rest will be up to you for switch familiarization, and we will see you again in the future for our glycol loop checkout. Thank you.